This is J. Mohan, Assistant Professor from the Department of Computer Science and Engineering, Velammal Engineering College. Today I am going to teach about describing data. Describing data. Today we begin with the foundational concept of describing data. Understanding how to clarify and interpret different types of data is key to any data analysis process. Types of data. There are three main types of data. First one is qualitative data, where qualitative data means it is non-numeric data such as responses like yes or no or categories like male or female. Second one is rank data. Rank data, it is the numerical positions like first, second, etc. that show relative standing but not measurable difference. Third one is quantitative data. It is actual numbers that represent count or measurement like height, weight, or test scores. Next is types of variables. Now let's define variables. Variables can be defined as qualitative, quantitative, and constant, where qualitative variable means it captures categories like hair color. Quantitative variables record numbers like temperature, weight, etc. A constant is a value that doesn't change like a fixed threshold. Quantitative variables. It is discrete variables represent countable values, typically whole numbers. Example, number of siblings, dice outcomes, coin toss results. You can't have 1.5 children or 2.7 dice rolls. These values are separate and distinct. Quantitative variables comes under continuous variables can take any numerical value including decimals. Example, weight, time, temperature. These values can be subdivided infinitely. Discrete versus continuous variable. This slide helps clarify the difference. Discrete equal to countable. Continuous means measurable. Independent and dependent variables. In the experiment or analysis, the independent variable is what you manipulate or consider as a cause. Example, age. The dependent variable is the observed effect. Example, test scores. A confounding variable can unintentionally influence results, something we must control or acknowledge. Describing data with tables. We use frequency distributions to summarize data. There are two groups of data. First one is ungrouped data, second one grouped data. Ungrouped data means it shows individual values. Grouped data, it organizes values into ranges or intervals. Guidelines for frequency tables. Here we must follow the important rules. First one, don't let intervals overlap. Second, include classes even if frequency is 0. Third one, aim for equal interval weights and prefer common intervals like 5 or 10. Relative and cumulative frequency. To give context to raw frequency, relative frequency is the proportion of total. Cumulative frequency adds up values progressively. Percentile rank tells what percentage of data falls below a certain value. Next one, graphs for quantitative data. For quantitative data, here we use histogram, frequency polygon, stem and leaf plot. Histogram means here the bars don't have any gaps. Good for continuous data. Frequency polygon. Line graph of histogram frequency is frequency polygon. Stem and leaf plot, it retains original data values while showing shape. Graphs for qualitative data. For qualitative data, here the categorical data is comes under qualitative data. Here it use bar graph with gaps between bars. Example, survey response on social media it uses either yes or no. Next one, describing data with averages. We've discussed central tendency like mean, median, and mode. These help us summarize a set of values with a single representative number. Describing variability. A variability shows how spread out the data is. Range equal to max minus min. Here, maximum value minus minimum value. Variance means average of square differences. Standard deviation is the square root of variance. Sum of squares is the total of squared deviations. Next, sample versus population formulas. Important to use the correct formula based on whether you are analyzing a sample or an entire population. Degrees of freedom and IQR. Degrees of freedom means here we use n minus 1 used in sample variance or SD. IQR, it is interquartile range. Q3 minus Q1 gives the middle 50% of the data. Next one, normal distribution. A normal distribution is a symmetrical bell curve. Here we use mean, median as well as mode. The total area under curve equal to 1. Here, common in test scores, heights, etc. are used in normal distribution. Standard Z-score. Z-score help standardize values. Here we use the formulas like Z equal to x minus mu divided by sigma. If the result is positive means it is above the mean. If the result is negative means it is below the mean. Here it is used to help in comparing values from different distributions. Next one, Z-scores. Z-scores help us in the possible ways like it is used to find the probability or percentile of a value. Convert a percentile back into a raw score using a Z tables to find these values. Thank you.